Hello and welcome to a new lecture in the series of ultrasound physics. And here we'll be talking about the role of statistics in the ultrasound quality assurance. The main objective of this lecture is to understand the role of statistics in the field of ultrasound scanning, and specifically in what we call the quality assurance or validation of some examination protocols. For example, we need to understand something. To understand this, we have to understand some definitions like what is the statistics, what is the quality assurance, what is the meaning of gold standard, and what does it mean a newer test. Out of this, we have to go for some data that we are collecting to feed the statistics procedures. So we have here something called the true positive and the false positive. Also, we have the true negative and the false negative. And then we have the chart that we are going to use in evaluation or validation of this test. And this is called the chi-square chart or the chi-square table. And also we have at the end of the lecture, we know how to calculate the basic statistical values using the chi-square test. So we'll start by the statistic, the word statistics. Of course, everybody knows that it is a science of making effective use of numerical data that we are having all over our life. We have a lot of numerical data, and how we can use them. This is the main goal of statistics in relating of the individuals or experiments. It deals with data collection, and then we analyze this data collected data, and then we go for interpretation. This is here is used to, in our field in ultrasound, used to evaluate the accuracy of diagnostic ultrasound testing. Specifically, we will talk about specific tests, which is the vascular duplex. Another term we are going to use is the quality assurance, and we already studied the quality assurance in the ultrasound system evaluation. We use the tissue equivalent phantom, we use the Doppler phantom. So in this way here, we are using the statistics to evaluate a test by ultrasound. And in here, we are going to use this test by having some data collected from the test all over many patients along many times, along many years. And we collect this data and put them in an evaluation against what we call a gold standard. So this is here, this systemic monitoring and evaluation of the new test to ensure that it meets the gold standards of quality. So as we see here, we have what we call the gold standard. The gold standard is already a well-established and reliable test that been proved against the years and years. And we are assuming that this gold standard is as accurate as almost 100% in diagnosing any problem. For example, we are going to use here in the ultrasound, for example, we are going to use the angiography as a gold standard, and we are going to evaluate the new test, which is duplex ultrasound. Another way that we might have, for example, liver biopsy, this is a gold standard, and we might evaluate the liver elastography to evaluate how accurate it is in diagnosing of, for example, liver disease, liver tumors. So this is what they mean the gold standard. The new test is the one that we are going to evaluate. We are evaluating this test against the gold standard. The best thing if we have the new test that would match exactly the gold standard in 100% of the time. So again, here we have the gold standard and the newer test. The newer test is the ultrasound the test of ultrasound that we're going to use against some gold standards that are being already in the field for a long time. Somebody will say, so why we should have to replace the gold standard? For example, because of the it's not safe 100%. For example, the angiography, we have some injections, we have a needle, we have a catheter, we have a chemical material, we call it the contrast material. Some people might have allergy to this contrast material. So again, there are some risks, specifically if you are going to use the X-ray, for example, in the angiography. So all of these are we call invasive procedure, and we want to replace it replace it with the new test, which is the duplex. But to replace it with the duplex, we have to first to evaluate the duplex, and we want to make sure that this duplex ultrasound is as accurate as the angiography. So we are replacing the angiography with a safer test, but is as good as the gold standard. The same thing, we evaluate the elastography against the liver biopsy. So these tests, guys, are new tests, the duplex or the elastography, and to be in accepted in the medical field, we need to know first how good they are, how accurate they are. So as we know now that we have something called the new test and a gold standard. Now we collect data from the new test, and we evaluate this data based on how accurate they are. For example, we have something called the true positive. A true positive means what? The new test says that there is a disease, and actually is agreed by the gold standard. So the gold standard said yes, there is a disease, and the new test said a disease. So the test here, we call it a positive test of the new test, is a positive test, and it's a true positive test. On the other hand, if the new test said that there is a disease, but the gold standard say no, there is no disease, you are wrong. So in this condition, we call it what is a false positive. So now we know what is the difference between the true positive and the false positive. Both the new test said they are positive, but one here is a true positive and the other one is a false positive. So these two definitions here are positive tests by the newer tests. But actually, if there is a true positive, means that there is a really a disease there. Well, a false positive means what? There's no disease, but is falsely diagnosed as positive, right? Now we come to the opposite. When the new test said, no, there is no disease. So this is a normal person. It doesn't have any problem with this test. So the new test said, no, there is no disease in this person. Okay. And the gold standard, yes, actually, it's a normal person. So we call this what is a true negative. So it's a true negative means that the new test said that there's no disease, and this statement or this definition is already agreed with the gold standard. What if we have the opposite? What we have a patient that is having a disease, but the new test said, no, this is a normal person, it's not a patient, there's no disease. So in here we have what we call, there is a negative test, but it's a false negative. So now we talk here about the negative test or the negative result by the new test. I might have the negative, but it's true negative, or a negative, but it is a false negative. So as we see now, we have 4 conditions. We might have a true positive or a false positive. We might have a true negative and a false negative. So already we have collected the results of the new test. These results are collected from several centers along many years. Okay, so this test doesn't take like a month or so, it takes many years. At the end, we come to the conclusion that this test is valid or not. So as we see here, we have what we call the chi-square table or the chi-square chart. This is the one that we're gonna receive all this collective data. So the collected data will be feeding inside this chart. This chart is called the chi-square table. What this chart is doing is taking the collected data, and at the end we will see if the results of these collected data are as good as the expected accuracy, okay, or they are not. The best thing if we have there is a difference, but the narrower the difference is, the greater the accuracy of the new test. Okay, the collected data will be entered in what we call the chi-square table or a chi-square chart to determine what? To determine the accuracy, sensitivity, specificity, positive predictive and negative predictive values. These are the definitions here. We are gonna explain them in a while. So as we see here, this is the chi-square table or the chi-square chart. And as you see, it has four corners, four squares inside. And we have one side, we have here what you call the gold standard, and the other side here is the newer test. And we know that the gold standard said that this is a positive or a negative, so this is a true or false, right? But here we have the newer test. This is the one that we're gonna test against the gold standard. So we have here the new test say that this is a positive, but as we mentioned here, we might have a true positive or a false positive. A true positive means what? Is agreed by the gold standard. The false positive means what? Is not agreed by the gold standard, is denied by the gold standard. So this is a false positive. So again, we put here the true positive and the false positive. And the other side, what we have from the newer test, negative result. A negative result, okay, and if you have a negative result, but it is not negative by the gold standard. There is a disease by the gold standard. So we have what we have here called what? This is called the false negative. And the other side here, in the last corner, we have here the true negative, meaning that the newer test said that there's a negative, but also the gold standard agreed with it. So it is a true negative. So again, we have here numbers. For example, if you have 5,000 cases, okay, how many of them are true positive? Both are done by the gold standard, these 5,000 cases, and by the new test. Okay, out of the 5,000, how many cases are true positive? I put the number here. How many cases are false positive? I put the number here. How many cases that they are false negative? I put the number here. How many cases are true negative? I put the number here. So the full 5,000 cases, they will be distributed along these four squares. Okay, so I have first to know how many of each quality. This is the true positive or a false positive, is a false negative or a true negative. So we put them here. As we see here, we have the true and the true are on the diagonal. The true here. So this is how you need to feed the chi-square in this way. The true here and the true here are on the diagonal, and the false are on the other diagonal here. So as we see here, we start put the two positive together. I'm giving you this example because you might have this in the SPI exam. You give you, for example, how many cases that have been met with the new test, and how many of them had true positive, how many of them have true negative, how many, and they give you the numbers, and then they will ask you at the end, for example, we calculate the sensitivity or calculate the specificity or whatever. So first you need to plot this square, and you put the true on the diagonal, the false on the diagonal, the two positive here and the two negative here. So this is an easy way to imagine the square in your mind. So when you go to the test, you can put it on your erasable chart, and you can substitute the numbers by these definitions here. So we need to first true, false, positive, negative. All right. So as we mentioned here that we have the four quadrants filled by the data already, substituted the numbers. And now we come to the results of what we can get out from the chi-square. The chi-square can give us 5 results. We have what you call the positive predictive value. like in this slide. We have the negative predictive value, it will come later. And we have the sensitivity and the specificity and the accuracy. So as we see, we have 5 types of results that we can get out from the chi-square chart. The first one is the positive predictive value. From the name, you can tell that this is the accuracy of the test, how accurate or how good proportion that it can pick the true positive. So if we have the test tell me this is a true positive, I can predict that this is a really true positive. There is no fallacies in this way. So this is I can predict the true positive out from the whole positive results. So for example, I get the test tell me that we have 100 positive results. I can make sure that almost 99 of the 100 are true positive. It means that it has a good predictive value. That is talking about what? The true positive results. So it provides the probable proportion of detected patients. Patients mean the positive, okay? With positive results that are correctly identified as positive. So this is a positive predictive value. Okay, is how we can calculate it. Take the true positive from the chart, divided by the whole positive, meaning that the true positive and the false positive together. So as we see here, the positive predictive value equal the true positive divided by the whole positive, meaning that the true and the false positive together. It is in the denominator, and the numerator we have the true positive. So as we see here, this is the proportion of the true positive among the whole positives. Okay, like I tell you, if you have 100 patients, okay, and they are already diagnosed by the gold standard, all of them are patients having the disease, okay, how accurate is the new test? If it reaches to, for example, 99, means that 99 of the patients, of the 100 patients, are already being detected by this new test. So this is what you call the positive predictive value. I can assure myself that I'm dealing with a good test in detecting the positive. So as we see here, this is the chi-square table to calculate the positive predictive value. This is here the true positive, okay, and this is the false positive. How can I get that the positive predictive value? I take the true positive, divide it by the whole positive, the true and the false positive. As we see here, positive predictive value equals A, which is the true positive, divided by A plus B. Take these together in the denominator, and the numerator we have A. So again, peso predictive value is A divided by A plus B. This is the positive predictive. I start from here going to this direction. Okay. This one is for the negative, and we'll come to this in the coming slide. So here is the negative predictive value. What does it mean? It means that the new test is accurate in detecting the negative, meaning that for example, I have 900 persons being diagnosed by the gold standard as negative. So there is no disease. And my test said that, yeah, I'm out of these 900, I get, for example, 890 are truly negative. So this is the accuracy of my test in detecting the negative or the normal persons. Say that I don't want to have a normal person and can diagnose it as falsely as a disease. This is a bad situation, of course. So negative predictive value means what? It provides the probable proportion of detected patients with negative tests, okay, that are correctly identified negative by the gold standard. Okay, so how much percentage I have, or how much is the ratio or the proportion of the negative patients that are already diagnosed negative by the new test. Okay, it could get all of them, the 100 or the 900, assuming that these 900 patients already, or 900 persons already are negative, and my test could get them all as negative. So I'm having a perfect test in what you call the negative predictive value. How we calculate it? Get the negative predictive value is how much the true negative divided by the true negative and false negative. Let's go to the chart and see how we can do that. So here is the chart. We have like omission error. This is a negative, okay? This is the negative here. So we start from this direction. What we call the true negative, okay, which is D, true negative D, divide by all the negative that diagnosed by the new test, all the negative, okay, the false negative and the true negative by the new test, okay, and I will see the ratio between the true negative among the all negative by the new test, and we have what we call here the negative predictive value. I mean that this test is good in predicting the negative persons. They are not disease, and the test say yes, they are not disease. Okay, so again, the negative predictive value starts from this square D and go in this direction. As we see here, for the positive, it goes from the square A and goes to this direction, and the negative predictive goes from this square and goes to this direction. So in this chart, guys, you can tell here, this is the first two results that we can get out from the chi-square, that I can get the true positive, sorry, the positive predictive value and the negative predictive value. Okay, positive predictive value, this is the positive, I go from here to this direction. This is negative, I go here, from here, and go to this direction. All right, guys? The next result is the sensitivity. What is the sensitivity? I'm testing my test, the new test, against all the positive that are brought by the gold standard. So I want to see how good is my test in detecting all these positive. I don't have false negatives. I need to have all the positive diagnosed. And this is here what we call the sensitivity. It's the ability to correctly identify the disease when the disease is truly present. Okay, I have, for example, 500 patients already diagnosed as patients. If my test could bring all of them positive, my test is good. So this is a sensitive test. It's calculated by what? Dividing the true positive by the whole positive results determined by the gold standard. And this is the sensitivity equals what? The true positive divided by the true positive plus the false negative. Okay, confusing? Let's go to the chart. So now we come here, this is the chart, and I put here the sensitivity, also the specificity. We'll come to this in the next slide, but let me here go by the sensitivity. What is sensitivity? I start from the gold standard. The gold standard say these are the positive here, okay? And my test is doing what? Is getting that positive here. I can diagnose them already as positive by my test, or they are false negative. My test said that they are negative, but actually they are positive. So they are, by my test, they are falsely negative. So, but they are already positive. These two groups are positive. So how good is my test to predict, or not to predict, to pick the true positive without or no or the least false negative? So this is the ratio between the true positive among the whole positive diagnosed by the gold standard. Okay, and the predictive values, guys, and the positive or negative, we start from here, the newer test. We start from here. Okay, positive predictive or negative predictive. But in the sensitivity and specificity, we start by the gold standard, because this is my standard now. I want to compare the result to the gold standard. So I start from here, the positive, and the positive here is the sensitivity. So start from the positive here and go down. This is the true positive divided by the true positive and false negative. This is the sensitivity. And as you see here, sensitivity equals what? A, this one, divided by A plus C. These are here. They are already positive by the gold standard, but some of them have been falsely diagnosed as negative. And I want to make sure that this number is the least or zero. So this is the higher the true positive and the lower the false negative. I'm having a sensitive test. All right. So this is the sensitivity of the test. Again, we start by from where? From here. Again, the predictive values will start from the the newer tests, positive predictive, negative predictive. And the gold standard, we have here sensitivity, and we have the specificity, as we're going to check it in the next slide. So again, we decided already three: positive predictive, negative predictive, sensitivity. We are going to study the specificity right now. So this is the specificity. Specificity means what? My test is specific. It doesn't lose any of the negative and bring them as positive. So it can pick the negative cases. This is specificity. Okay. Negative cases means what? They are not disease, and my test is specific enough to tell they are not diseased. Okay. So they are already negative by the gold standard. But when it comes to the new test, okay, my new test said that out of, for example, the 500 cases that are negative, my test diagnosed negative, for example, 499, meaning that my test is very specific to detecting the negative cases. So specificity is what? The ability to correctly identify what? The non-disease, means that the negative, when they are truly, there's no disease. So this is the specificity, or my test is specific or not, okay, based on the chi-square table. It's calculated by what? Dividing the true negative by all the negative. So this is specificity, true negative divided by the true negative and the false positive. Okay, confusing? Let's go to the chart. So here is the chart we have here. We mentioned earlier that this is the sensitivity, starting by the gold standard positive, going down, sensitivity. When you come to the specificity, this is the negative. Specific to the negative, right? We mentioned this. Sensitive to the positive, specific to the negative. The test is sensitive to the positive, specific to the negative, okay? So if my test is a good specificity, it means that it can tell me out of the whole number that are negative here, my test get, for example, 499 out from the 500 here. So I'm having true negative 499 and false positive 1 only. So again, here we have the 500, 499, the truly negative, and only 1 true false positive. And so it means that my test is highly specific. Again, sensitivity to the positive, specificity to the negative. All right, guys? So these are here the equation, or how the formula for the sensitivity. Again, sensitivity, you have the A divided by A plus C. Okay. Specificity, you get D divided by D plus B. Okay. So these are the specificity, sensitivity, positive predictive, negative predictive. Now we come to the last result from the chi-square, which is the accuracy. Accuracy is what? It's the combination of all of these, a combination of the positive predictive, the negative predictive, the sensitivity, and the specificity. The last four diagnostic results that we had already, okay, the combination of all the what you call the summary of all of them is the word accuracy. So accuracy is what? The percentage of the overall correct results, the true positive and the true negative, among the whole number. So it's important to be correct when disease is present, as well as when the disease is not present. This is the sensitive and specific. This is the accuracy here. How we can calculate it? How we can calculate it? Okay, we'll come to this in next slide. But first here, we need to know that the value of the accuracy must be between the values of the sensitivity and the specificity. Also, between the negative predictive and the positive predictive values. This is, like I mentioned earlier, this is the result or the average between the whole four tests or the 4 results that we have with the test, okay? This calculated as what? The total number of the true positive plus the total number of the true negative divided by the whole number of the whole tests, the whole cases, okay? So how this is calculated, the accuracy is calculated, okay? We go here by the true positive, like I mentioned earlier, the diagonal, remember? The true positive here, we come to the diagonal, true positive plus the true negative. So these are the good results or the accurate results, the accuracy of the test. Among what? Among the whole 4 quadrants, okay? The whole 4 quadrants. So as we see here, accuracy equals what? A plus D divide by the A, B, C, and D. All of them together, they are in the denominator. And the A plus D are in the numerator. This is the accuracy. Again, the accuracy, the result of the accuracy should be between the sensitivity and the specificity. And also, the value will be between the true positive and the positive predictive value and the negative predictive value. So it's the average among all of them. And how we can calculate it? Add the true positive together, the come from this diagonal going in this direction, and this is the, the true positive and the true negative, divide by the whole numbers, the whole number of patients. And the more the accurate, the best the result we have. Something to mention here, okay, is called the reliability. Reliability means what? The test can stay accurate. How many years? It means that it can stand the test of time. Test of time means that this test is valid and gonna be used for example, the coming centuries, okay? Based on what? Based it's being reliable. Reliable means what? The consistency of the accuracy, of course, of obtaining similar results, similar accurate results under similar circumstances along many years. So it is the accuracy along a period of time, okay, in different consistencies, in different, for example, geographical, ethnical, whatever the age related, gender related, all the circumstances are variable, but still the test is reliable. So this is against the time, against the other conditions of the patient, the conditions of the hospital, the ethnic groups, okay? All of these are factors, but if my test is reliable, it can stay as accurate as possible among all these conditions. So this is what we call reliability. It's not one of the chi-square, but this is the outcome of the accuracy. If the accuracy is it could stand the test of time, so it's called a reliable test. So as you see here, this is the summary of all the 5 tests that we have. We have the sensitivity, okay, how to calculate it, the formulas, okay. The sensitivity is the positive predictive, the true positive divided by the true positive plus false negative. The specificity is the true negative divided by true negative plus false positive. The positive predictive, this is the one that goes in the direction, the horizontal direction. You have the true positive divided by true positive plus false positive. And the negative prediction, negative predictive value, the opposite direction in the horizontal also. We have the true negative divided by the false negative plus true negative. And then you have the accuracy, the true positive plus true negative divided by all the 4 squares. This is the summary of all the chi-square. And best of luck, guys. Okay, thank you, and hope that was beneficial for you, and good luck in your SPI exam.